Okay, 7th grade, our learning target today is I can determine if a relationship is proportional using a table, graph, or equation, which also means is it in direct variation. So our learning target really is direct variation and proportional reasoning. They kind of work together. So what is direct variation? Direct variation means that the ratio of one quantity to another is constant, or it's the same. So the unit rate is the same, the slope is the same, you have this constant, what we say K value. So we have this K value, unit rate is the same. What is another name for direct variation? Another name for direct variation is proportional, that it is proportional, that same word that's written in our learning target. So you can just copy it from there, right off the top of your sheet if you're not sure how to spell it, proportional or direct variation. Now we just talked about proportionality a couple of units ago, and we had two fractions that are equal to each other. So we're going to talk about that same idea in our work today. We will do all of our work today through a table, a graph, an equation. So everything that we do today, we're going to demonstrate proportional reasoning through a table, a graph, or an equation. I'm going to start with what I think is the easiest of the three, the graph. So how do we know when a graph is proportionate or it's showing proportional reasoning? The way to check for that is to check to see if the graph starts at 0 or if it goes to the origin. So if we take the Valley Fair analogy, the Valley Fair analogy says that in order to get into Valley Fair, you have to pay $30 to get in, $30 at the beginning, the B, the y-intercept in our last lesson. The analogy we're looking for today is, where would we go or when would be a case where we walk in the front door and we don't have to pay anything to get in, where we have a starting amount of 0. Here's our y-intercept, there's our y-axis. When would we pay $0 to get in? And that example would be really Como Zoo. You walk into Como Zoo, do you have to pay to get in? No, $0 at the beginning, so we have this 0 y-intercept. If you choose to go on rides or get some food after that, then that would be a choice, and that's where your slope would kick in. But our beginning amount is 0. So in this graph on the left here, we have this line sloping upward. It's hitting the y-axis right here at 0. So you'd say, yeah, this is proportionate. It starts at 0. We don't have to pay to get in. If we look at the graph on the right, we would say that this one is not proportionate because it does not go through 0, 0. It hits the y-axis down here at -1, -2. It looks like it hits the y-axis at -3. So our B value in this graph is -3. It does not hit the origin. Nope. So that is not proportionate. So it's pretty simple to see in a graph whether something's proportionate or not. You just simply look at the origin 0, 0. Does the line go through the origin? Yes or no? And there you have it. So that's proportional reasoning with a graph. In a table, we're looking for this idea of whether something's constant. We're going to do that by simply taking the data from the table and we're going to be graphing it. After we have the graph of it, we will check to see if it goes to the origin. So we're still looking to see if something has this constant value, if it has a constant K, but we're going to graph it. So we have the elevator analogy, and then we're going to go up and down. So we're going to go find the elevator. So we check in at the front door and call the origin. Check in, ask, hey, where am I staying? They say, where's the elevator? The elevator is the first door on the right. Once you get in the elevator, you're going to go down the floor. So we're going to go to the right one, down a floor. Then, elevator is located at 2. So we're going to go right 2, down, or right 2, and we're going to actually stay there. We're not going to make any change in our Y. So right 2, stay there. Then we're going to go find the elevator is located at 3. 1, 2, 3, up 1. Go find the elevator is located at 4, and then we're going to go up 2, right? 1, 2, 3, 4, up 2. So we have this line that's increasing with slope. It does not, however, go through the origin. Here's our origin. Is it hitting the origin? No. So we would say this is not proportionate. The reason why is it does not go through the origin, 0, 0. Proportionality. So far we have seen it in a graph, checking to see if it goes through 0, 0. We just saw it in a table. So we take our table, We plot our data and we check to see, does it go through the origin? If it does, we say yes. If it does not, we say no. So the third type is something proportionate when it is in equation form? So we're still looking for this idea of whether it is constant or not. Does it have a same constant value? This one's a little bit different because we don't have a graph to fall back on. We can't check for 0, 0 right away. We have some steps involved. So the first thing that we're going to need to do is we're going to need to check that in our equation if we have y alone. And what I mean by that is, do you have just y equals without anything else attached to the y? If you do, then you should go to step 3. If you do not have y totally alone without anything attached to it, then you should go to step 2. Everybody should be writing. In step 2, if you do not have y alone, then our job will be to solve for y. So if you do not have y alone, then you need to solve for y. So if you do not have y alone, then we have to solve for y. Okay, everybody should be writing. So we'll practice that as we get down below. We're just going through the steps first. And finally, we'll need to check for proportionate, like we did in the table and the graph. To check to see if something is proportionate, you check to see if it goes through 0, 0. Is it true that I don't have to pay anything to get in? So we would be plugging 0 in for x and 0 in for y as soon as we have the equation ready. So this is going to feel like the hand method. It is the hand method. But the problem that we will have in this particular example is that we will not be able to solve to its entirety. We won't be able to get just a number value. Most of us don't feel very comfortable when there's still a variable in our answer. But that's what's going to happen in our work today, because the problem is we have 2 variables right now. So we will not be able to solve all the way. So our job is to first of all look at step 1. It says if you have y alone without anything attached to it, then go to step 3. We do not have y alone. If I were to highlight the y here for you, there's my y. Is it alone? No. What's attached to it? Subtract 3. You know in my class we always stop, chop everything. So what am I going to get rid of then? I need to get rid of this -3. How do I get rid of it? I do a +3, copy, paste. On the left-hand side of the equation, as I read down, that's x plus 3. If I haven't used it, drag it down. My variable is y. +3 and -3 is 0. And now I have y, so totally alone. Now that y is alone, I can go to step 3. It says check in step 3, check to see if it goes through 0, 0. How do we do that? It says plug a 0 in the x spot, in a 0 in the y spot, and see if it is true. So we're looking to see if it will be true. So I'm going to take a 0 and plug it in for x, a 0 and plug it in for y, and see if this equation makes sense. So we have 0 plus 3 equals 0. Is it true that 0 plus 3 equals 0? Well, no, because 0 plus 3 equals 3, and 3 does not equal 0. So this is not proportionate. It does not go through 0, 0, because when I plugged in 0 for x and 0 for y, it did not work. Example number 2. What do we do for an equation? Well, we looked at the steps for equation, and then if we go back up to our steps for equation, step number 1. If you have y totally by itself, then go to step 3. So if I look at my y value and ask, is y alone? It's not alone right now. There's division by x attached to it. So I have to get rid of that in order to get y alone. So I'm going to multiply. Since I have division by x here, I have to get rid of this. So I'm going to multiply nice and high. I'm going to multiply by that x to get rid of it. We have a rule of math that says whatever you do to one side, you have to do the other side. And in Wilson's class, we call it copy paste. So we're going to copy paste that same skill. Those x's then cancel, and then we get that nice 1y on the left-hand side of the equation. On the right-hand side of the equation, we have 4 multiplied by x. Our job is to get the y home alone. We have it home alone, so we have y equals 4x. My question, though, is really question step 3. In step 3, it's checking to see if it is proportionate, which means does it go through the origin 0, 0. We are going to take a 0 and plug it in for y. And we're going to take a 0 and plug it in for x and see if it's true. You can use your calculator if you need to. Is this true? Is it true that 0 is equal to, well, what is 4 times 0? You should be saying, well, 4 times 0 is 0. Is it true that 0 equals 0? Yes, that is true. So yes, that is proportionate. Okay, so meet me on the next page. On the next page, on page 21, there are all three types of problems on this page. On the left-hand side, you have the equations. So for all of the equations on the left-hand side, you're going to need to get y alone. If we look at number 1, y is alone. So you can go, this is an example where you can go all the way to step 3 because you already have y alone. So then you would just be plugging in a 0 for y. You'd be plugging in a 0 for x. And you're asking, is this proportionate? Well, is it true that 0 is equal to, what would we get here? 4 times 0 is 0. Is it true that 0 equals 0? Well, yes. So yes, that's proportionate. Now, as you scroll through the left-hand side, and you're getting that y totally alone, you're going to have some work to do on some of these, because if we look at example 4, is y alone? No. Is y alone? No. This plus 3 is here. How do you get rid of the plus 3? Minus 3 before you can plug in. In example 6, is y alone? No, there's a multiply by 5 there. You're going to have to divide by 5, copy, paste. In example 8, is y alone? No, you're going to have some work to do. In example 11, is y alone? Yes, so then you can plug in. So your job is to be working on that for homework tonight. In example 2, all of the middle graphs, everything in this middle column, everything down this column, you're checking just the graph. You're checking these origins. Does the line hit the origin there? No. Does the line hit the origin there? And so on. And finally, in example 3, your job is to graph this. Once you graph it, you're going to check to see if the graph hits the origin. Remember, this is the elevator analogy. Go find the elevator and then go up 4. Find the elevator, go up 2. Find the elevator, not moving at all. Find the elevator, go down 2, and then plot your points. Your job is to finish this page for tonight and the next 2 pages for homework. So your homework would be to do pages 21, 22, and 23.